Hello, I'm Gerard Fisher from RAP, and I'm directing the project at RAP on the development and implementation of buying guidance and specifications for buyers and specifiers of electrical and electronic products in the retail sector. As part of this work, we've developed summaries of different product categories in order to identify where failure modes are occurring and how they can be avoided through specifying components, design, and user guidance best practice. This webinar will focus on washing machines. After reviewing the project objectives, Lee Holloway of Eco3, one of the technical experts who's helped to develop this product summary, will talk through the key highlights of the summary. Finally, I'll conclude the webinar and discuss next steps and where to find further information. Through RAP's Electronic Products Pathfinder Group, industry recognised a need to identify design changes needed to increase the life of selected electrical products by bolstering durability. The end result will be guidance development for technical managers, buyers and suppliers to provide industry standard accessible content. A first step has been to research the most common failure modes within the product summaries, which provide a first step towards the development of more detailed guidance documents. In partnership with the Pathfinder members, we've selected washing machines, fridge freezers, vacuum cleaners, microwave ovens, kettles and televisions for assessment in these product guidance notes. The structure of the summaries is the same for each product and will include an introduction on how to use the document, the short-term failures that may result in a product being returned to you, the long-term failures that prevent it from reaching its long-term life, and then best practice in terms of component specification, design and user instructions. Finally, it will identify the opportunities for lifetime extension. So now for more detail on this product, I'm handing over to our technical expert.
Thanks, Gerard. What we're going to do now is look at the washing machine summary in a little more detail to try and explain to you the type of information that's held within it. During the work we've carried out considerable research into this particular type of product and the way that faults occur, and the type of faults that occur and also when they may occur during the life cycle of that particular product. So we can split it into what we would call short-term faults and long-term faults. We'll just have a quick look at some example causes here. We have a list of washing machine short-term faults here, which could range from a dirty tray and seal, noise, excessive noise or unexpected noises from the machine, electronic faults or electromechanical failures such as valves, physical faults like the drum paddles physically falling off the drum itself, and other issues such as door interlock, latch failures, etc. These are all faults that have been observed in washing machines. They may not be exclusively short-term faults, but they tend to be a shorter term period of time before these actually occur. And as you can see there, what we've also identified is the causes of these. So the dirt in the tray and the seal tends to be caused by low temperature washing, or user error whereby the user is overdosing the machine with detergent, or where they're not undertaking a service wash which is required every so often to clean the machine out. Noise could obviously come from foreign objects which have fallen out of pockets in the washing, or items that have fallen off, items of clothing. Also poor design, counterweights and dampening within the machine itself. If that isn't carried out correctly and executed correctly, then you can get excessive noise when the machine is operating. Obviously electronic faults and electromechanical faults can occur at any time, but these could be things like the controller board or the motor controller failing. That could be physical failure, but it could also be failure through water ingress. Valves will also fail over a period of time. We have seen cases of drum paddles physically falling off the washing machine drum, and this tends to be down to the type of design and the type of fixing. And door interlock and latch failure generally comes from poor design, poor quality of materials and manufacture, but it can also come from user error if users actually sometimes lie wet washing on top of the door of the machine itself. This can put extra stress on the hinge and can cause failure. So this is what we've identified as short-term faults. We've also identified some faults which are longer term, tend to occur later in the lifetime of the machine. One of these is motor failure, and this could be through brushes of motors failing or windings of the motor burning out. Bearing failure, there's a very large main bearing in most washing machines that holds the drum up. This can fail, can be poor design of the bearing, not to the correct quality or not specified to the correct number of cycles, but it can also be water ingress through a seal if there's a bad design there. You can also get filter and pump blockage, again user error, poor filter design. If users aren't emptying the filter every so often, which it will need to be done, then this can cause problems. Another known failure with washing machines is the heating element failure. Again, any heating element can fail over a given period of time. Tends to be further into its life that these things will happen. And again, it's generally down to the design and manufacturing materials used in that particular element will set how long it may last. And then finally, the other long-term fault we identified was control faults. So fascia switches, dials, etc. could become broken, disconnect themselves, stop functioning. Causes could be many. It could be misuse by the user, but it could also be down to quality of materials and whether or not they've been designed to actually last the correct period of time. So once we've identified these faults, we can try and identify some best practice activities which will help to address these issues. So if we look here on the slide, we have a whole number of things that could be considered best practice. You could look at component specification, testing standards, general design criteria, and also user instruction, particularly with a washing machine because of the way they get used and because of the interaction with the user choosing temperatures, changing wash cycle times, choosing what detergents they use. User instruction can actually be very important. But if you just take some examples here of what you might want to consider, under the specification, component specification, you may want to specify a motor with a given life. For example, you may say all motors in our washing machines have to have a 3,000 hour life with no maintenance, which may equate to 8 or 9 years worth of usage. You may specify the same for bearings and seals. You may also start putting specifications down against paddles, latches, hinges. RAP also has some buying specifications for repairability aspects of products, which also will affect overall reliability, which you may want to take a look at. There are no specific testing standards on washing machines in terms of durability, even in the latest eco design regulation. There are EU eco labels which will specify years of warranty and how long parts have to be available after a machine is placed on the market. There are some generic standards and performance standards, but really nothing exists specifically for durability in washing machines. You may want to look at design, best practice in design, and again it's all about obviously the functionality of the machine, and the main aim is to use as little energy and water as possible, reduce noise, give a good wash performance. But good design for durability may include some extra features as well as ensuring that the materials and components are up to spec. It may be filters, it may be issues such as flagging when a service wash cycle is needed, or flagging when a filter is blocked, or a load sensor or uneven load protection to communicate to the user that they're maybe not using it in the correct way. As we said, user instruction can be very important with washing machines because of the way that people use them very often, but also have the ability to influence a lot of things within the machine. So we might want to communicate to the user the need to clear filters and things like that. Any of this type of information needs to be clear and short with diagrams. It needs to be easy for the user to understand. It needs to emphasize certain things, so it may emphasize the need for correct dosing of powder or liquid detergents. It may emphasize the need to clean the filter, but actually say how to clean the filter or the trays or the seals. So the product summaries will contain some best practice information like this, and then we they go on to just look at generic design issues for durability and reliability. So with washing machines, there are a number of issues that really need to be considered. Pumps, motors, electronics and casings need to be robust and fit for purpose and up to the job in terms of predicted life. User interaction, as we've said, is very important. Correct choice of materials and good manufacturing quality make a big difference to reliability. And achieving good reliability will require a mixture of engineering design, expertise, good quality manufacturing, and testing where it is appropriate and where testing can be carried out that's meaningful. So the final thing within the product summaries will be what we call example opportunities. So we've identified faults, we've looked at best practice, and now we've offering some example opportunities in terms of making a product more reliable. So you've got two shown here. We identified the failure mode, which is the motor. The cause of that, well, it could be worn brushes or an overload. It could be burnt out for a number of reasons. Where that failure occurs, be it early or late within the product's life cycle. And then there's an identified opportunity. So the opportunities here for motor failure will be to fit a brushless motor, which tends to be more reliable. Some of the brushless motors have been certified for at least 20 years worth of use or 4,400 cycles. You could, if you have to keep a brushed motor, just fit longer brushes so they take longer to wear out, improve the quality of the windings on the motor, improve some of the electronic and electrical protection, surge protection in there, as well as fitting, for example, thermal overload switches that can be reset. So rather than a motor failing because of overheat, it will actually trip out and reset itself. We then identify how this might be done. So you might increase the reliability of your motor by providing the manufacturer with specific design specifications. You may specify test standards or performance requirements where they are available. And the cost implications, we also try and take into account some of the costs that these opportunities may bring. So brushless motors are more expensive, so you would have a small uplift in manufacturing cost. Reset switches will also cost, but these costs have obviously got to be balanced against the fact that you will be producing a more reliable machine. You will see less returns under warranty, hopefully, and you will also see better customer satisfaction, which could lead to more sales. So that's an example there for motor. Bearing example is underneath, which you can read in your own time.
Thank you. Full product summaries for all products will be available for download from WRAP's website from January 2014. Full guidance documents will be made available by March 2014, and there'll be further engagement on the format of these documents. For further details, please contact WRAP through Claire Ollerenshaw, the project manager, at claire.ollerenshaw@wrap.org.uk. Thank you for listening.